everyone. Welcome Data Bees. Where are you joining us from today? For those of you who are new, welcome. My name is Maddie Watt. I am the Senior Manager of People and Programs at the Hive, and we are so excited for today's event, whether you're joining us from the United States or maybe perhaps from Malaysia. We'd love to know your location. Can you go ahead and share it in the chat with us, please? I personally am joining from the Bay Area. Okay, great. And we're going to just get started here. Real quick, I want to remind everyone of the ground rules for the webinar. It is being recorded and it will be sent out to you automatically tomorrow. So if you can't stay for the whole session, don't worry, you'll get that recording. And also, we love questions. So to ask a question, please use the Q&A button. It is located at the bottom of your screen, and that's the best way to ask questions for our presenters. So without further ado, today we're going to talk about the future of cities and are they going underground? We are so excited to be having an incredible panel of master tunnelers led by Gamuda. So Ravi, can you do the next slide for me, please? Thank you. But real quick, what is the Hive think tank? We are an ecosystem of entrepreneurs, corporations, and thought leaders. We are an event and content platform that is hosting events about every other week, and we focus on things like AI, data, blockchain, supply chain, industrials, the future of cities, in entrepreneurship, health, and other things like that. And we are so thrilled to be partnering. Next slide, please, Ravi. And with our sponsor, Gamuda, on this event today. So if you want to learn more about sponsorship, please reach out to me. I will share my email in the chat. And we have another event for you guys in the new year, Insurance for the Sharing Economy. I will share the link for that registration, which we just opened up today. And that is going to be on Tuesday, the 25th. And that will be a special session that will be 2 parts. So it's going to be a 90-minute session. Again, I will share the link for that in the chat. And without further ado, I want to hand over the mic to TM Ravi, the Hive's Managing Director and founder. Thank you, Ravi.
Thank you, Matty. So the Hive is an early stage venture capital fund. And in particular, we are a subclass of venture capital that is called a venture studio. So we collaborate with entrepreneurs to help them start companies or get involved in early seed stage funding of companies. And so you'll see sort of our thematic focus is around sort of fulfillment and supply chain, fintech and insurtech, industry 4.0, health tech, to name some of the areas where we have a heavy focus. And we're always looking for how deep tech, data, and data-related techniques can drive that differentiation and new opportunity. We have a global footprint. So in addition to the Hive in the US, and I'm today in Palo Alto, California, we also have a separate Hive in Brazil, in India, and most recently, as part of the Dana Panjana program, we have created the Hive in Southeast Asia. So I would like to introduce my colleague, Haizam, to talk a little bit about the Hive Southeast Asia.
Yeah, good morning to everyone in Malaysia, and good evening to all of you in the US and beyond. Yeah, so I'm Syed Haizam, the managing partner of the Hive Southeast Asia. The Hive Southeast Asia is a collaboration between my venture capital fund, Tuas Capital Partners, with the Hive and Sunway as an ecosystem partner. Earlier this year, we received the mandate under the Ministry of Finance's Dana Panjana National Program, which is a public and private sector one-to-one matching program to invest into early stage innovative companies to drive economic recovery, as it was part of the Panjana Economic Recovery Plan. By harnessing the power of innovation to digitize businesses into the 4th industrial revolution. Really, what we're doing is we're looking at co-creating and seeding companies that will drive Malaysia into the 4th industrial revolution. We're really excited to partner with the Hive. As you can see, the global collaboration with the Hive, not just Hive in the US, but Hive Brazil, Hive India, and in the future Hives throughout the world. About 50% of our capital will be in corporate co-creation. So obviously Gamuda is a corporate co-creation partner of the Hive in the US, looking to invest into companies that will be able to plug into Gamuda's ecosystem. And in Malaysia, as you can see on the right, we are also partnering with Sunway. Sunway is asking us to look into vertical farming, specifically to solve and answer issues within the food security problem statements, and also partnering closely with Bausted, group of companies to digitize the whole group. We are also partnering with a few state governments in the digitalization plan and smart city plans. So really looking forward to looking for companies to invest into, and also partnering with corporates, and really looking forward to hearing the three distinguished gentlemen from Gamuda discussing their plans for innovation in Malaysia. And hopefully the Hive Southeast Asia, with the help of the Hive, will be very much a part of not just digitizing Gamuda, but digitizing Malaysia as a whole, and region as a whole. Thank you, Ravi.
It gives me great pleasure to introduce the panel here today. Gamuda, as many of you know, is really a world leader in tunneling, and especially kind of autonomous tunneling. And that's the topic of today's discussion. I've known Danny for some time. Danny is the group managing director and the chief investment officer of Gamuda. Danny and his team here of Justin and John, in my sort of humble opinion, are really sort of the top brains of the region, and really kind of, when it comes to tunneling and autonomous tunneling, really leaders globally. And so with that, I'd like to hand it over to you, Dan.
Well, thank you, Ravi, for that flattering introduction. And we thank you also for having us on board with the Hive, and now we're part of the Hive. And obviously, we look forward to synthesizing a lot of innovation out of the state, Silicon Valley, and bring it over to this part of the world as well, and even vice versa. So without further ado, we've got just a couple of slides that we want to talk through before we do the Q&A. Okay, so I just like to have a brief introduction of who we are first, and I suppose the story of how we get from, we started, like most companies, above ground, and then we went underground, obviously in a completely legal way. Going underground, we meant literally going underground. So, okay, so we have, Justin, let's go to that global map of at least where we are geographically. We are predominantly based in Southeast Asia, of course, in our home nation, Malaysia, but we are doing several underground projects and bidding for them as well in other countries such as Taiwan and a lot in now Australia, looking at Sydney, Melbourne, and so on. We have done projects in the Middle East as well, Bahrain, Qatar, India, although those projects were literally above the ground, typical infrastructure projects such as airports and so on. So we are one of the leading, if not the leading, engineering construction groups from Malaysia. And on top of that, we've diversified as well into real estate, where we have also done what we call digital industrialized building solutions, where we basically factory build homes for you. Unfortunately, we can't do that yet in the US, but who knows, that might be coming soon with your help, Ravi. So, okay, that's just a little bit about us and what we do. But our main focus today obviously will be our story underground. So as I mentioned, these are the three core businesses: engineering and construction, property development, and of course, we turn the infrastructure into businesses as well in terms of our concession businesses where we monetize those cash flows. Okay, next. Right, so this is how we all got started. And, you know, if you're interested, I think Discovery Channel made a full feature-length documentary on this very piece of infrastructure. It's still the only one in the world. It's called the SMART Tunnel, S-M-A-R-T. What it stands for is Stormwater Management and Road Tunnel. So the acronym is SMART. And what it does is Kuala Lumpur basically sits in a valley, and we have a tremendous amount of thunderstorms throughout the year, being in the equatorial country. So we were very prone to flooding. In fact, the word Kuala Lumpur means muddy river bank in Malay, and those river banks would just burst, and the rainwater into the two rivers that make up Kuala Lumpur, or at least the heart of Kuala Lumpur, would overflow, and it'll be quite terrible actually. So Gamuda gave a solution, which is to build a tunnel, obviously, to take all that water out, you know, millions of gallons of water. But of course, these thunderstorms or those sort of city flood events don't happen every day. So therefore, the innovation here is actually also on financing to help fund this huge infrastructure. It was a private enterprise at the time, public-private partnership, of course, funded totally by us, which is the private sector. What we did is we then combine a road tunnel, a double-deck road tunnel, as you can see on the right-hand side, with the same, in the same tunnel as where the stormwater would go to. So when it's dry, of course, the cars can go through it. But when there is a thunderstorm, then obviously the cars will be prevented from going into the tunnel, and water instead will be diverted through this tunnel away from the city. And since the construction, we have completely avoided large disaster flooding in Kuala Lumpur. So as I mentioned, if you know any infrastructure geeks amongst you, there is a full Discovery Channel feature on how this was made. We won't go through that today, but I just wanted to say, with this particular innovation, and as you can see on the left-hand side, we won several awards, especially from the British construction industry in 2008. That was when it was complete. We won the best tunneling or international tunneling project at the time. So this got it started. Next, as I said, it remains the one and only stormwater diversion tunnel in the world. And if anywhere in the States has this problem, Ravi, let us know. Obviously, we can provide the solution. So it has these several modes. Mode 1 is when it's dry. And as you can see, mode 4 is when you have the worst thunderstorm. The whole tunnel is taken up. Mode 2 is quite light. The cars can still go through it. Mode 3, it gets a bit heavier. So for safety reasons, we shut the tunnel. And yes, not a single car had been stuck in the water, in the tunnel itself. They are pretty sophisticated systems to ensure that doesn't happen, obviously. So this is the operation of that tunnel. Let's go to the next slide. And as I mentioned also earlier, we are looking at a job. In fact, we've already clinched it in Taiwan. And here we're building about just under 4 kilometers of a 43-kilometer basically public transport rail line It's basically constructing two parallel underground tunnels together, two underground tunnels and two underground stations as well. Okay, and here the key complication in Taiwan is, of course, the soil conditions as well as earthquakes, which is a key concern in Taiwan. All right, next. Of course, with the success of our smart tunnel, we then became tunneling experts. I just wanted to say a thing or two about the geology of the Malaysia terrain. So as I mentioned, Kuala Lumpur means the muddy riverbank. So basically the soil conditions in Malaysia is essentially quite soft. It's called karstic limestone. So if you tunnel within relatively soft ground, it becomes very dangerous because it would affect other parts of the surrounding area, and you might have this or create humongous sinkholes in the process that can either swallow up whole highways or swallow up buildings. So it is an exceptionally difficult thing to do, and until we had come onto the scene, it was generally taught by the tunneling industry that tunneling in a place like Kuala Lumpur would be impossible, which is why prior to that date, even though other countries like yourselves had underground metros many years ago, but for us, because of the geological conditions, it was very dangerous until that time. Having said that, we then basically put in the innovation of something called a variable density tunnel boring machine that can do exactly that. They can sense the surrounding ground area and do the tunneling in a very careful manner, all by itself, basically, without creating sinkholes. And the gentleman that I'm going to have speak to you later are part of the brainchild of this whole project. So there we go. We then obviously have succeeded, and now we're building the second MRT or mass rapid transit line. It is 13.5 kilometers of twin board tunnels. The tunnel diameter is huge. It's just shy of 7 meters. We have 12 tunnel boring machines, all with the variable density technology that I've just mentioned. And the tunneling depth is about 60 meters underground. The whole underground contract works is just over $3 billion. So this is going to be completed very soon. Actually, it says 2022 there, but we've essentially already completed our portion, and hopefully the first phase of the line will open very early next year. Okay, next. So I'm proud, very proud to announce that this is, as hot off the press, really, that in the equivalent Academy Awards of tunneling, and there were 3 major institutions and organizations that give these awards. We had a clean sweep of basically the Best Picture Award or the Best Project Award. And you can see the pictures of our Oscars there and us receiving it. So we bagged all 3, which is unprecedented, really. So from the International Tunneling Association, the New Civil Engineer Tunneling Organization, as well as the Ground Engineering Award. So we've got Project of the Year just recently for 2021 for this particular project. And you can see our team receiving it down there. And we have some other awards to just share with you. Next, Justin. Yeah, so this one you can literally see Justin right there in the middle with John receiving these awards, and deservedly so. because these are the innovation awards. And this particular innovation awards, again, multiple award that was provided, two in fact, one from the New Civil Engineer Tunneling Organization and the other one from the ITA again as well, International Tunneling Association. So here the award was given to for these gentlemen and Gamuda, where they had created again a world's first, an autonomous tunnel boring machine. So yes, we sort of pip Elon Musk to full autonomy, where the tunnel boring machine becomes a giant earth-eating worm all by itself. It knows exactly what to do, where to go, and it does all that in a completely health and safety priority environment, where this is why the innovation was even done, so that it removes a lot of the manual input under very tough conditions underground, and obviously many lives saved, many injuries are avoided, and it can do so very safely to all infrastructure above ground as well. So well done to Justin and John. They'll talk a bit more about it. I'm sure you are curious on what exactly is an autonomous tunnel boring machine. Very simple. Layman like me would just say it's a giant mechanical worm underground with a brain of its own. That's how it works. Okay, next. And here, for the variable density tunnel boring machine, this is where it was a major breakthrough at that time, where we managed to successfully tunnel through very difficult karstic limestone geology using this innovation method. And to this day, we are the world's leading expert in this particular technology. Okay, next. Okay, so now as we move actually underground and talk about more details of the project, I'd like to invite Justin to take it on from here and share with you basically the technical details and the challenges that we face. Over to you, Justin.
Thanks, Danny. Hi, my name is Justin Chin, and I'm the Managing Director of Gamuda Engineering, which is, as evident by the name, the engineering arm of Gamuda Group. So over the next 10 or 15 minutes, I'll take you through some ideas on why people choose to go underground, as well as a brief history of tunneling, and some modern day challenges of building underground, before I pass you on to my colleague John for the last bit of our discussion, which will be on tunneling innovation. So why do people go underground? Perhaps before I begin, I would like to qualify that, strictly speaking, the term underground doesn't always mean beneath our feet. When I say underground, I could also be referring to a tunnel built through, say, a mountain at high elevations, because the technology and methods utilized are quite similar. So anything that has ground above it is considered as underground. So one of the reasons that cities go underground is because of topography and geology. For example, some cities like Hong Kong are built in very mountainous and hilly regions, and this lends itself quite naturally to underground development and a lot of tunneling. With such natural conditions, it's often more economical to go through the steep terrain rather than above it or around it. Also, if the rock and natural geology in the region is very hard and self-supporting, so if you dig a hole through the geology, it stands by itself, essentially, then underground construction can also be relatively cost-effective. And I say relatively, but I'll come to that later. So you can create huge underground caverns, huge underground spaces, and use this space for a variety of things. People also go underground, obviously, because of a shortage of space, particularly given rapid urbanization in many cities around the world. Underground space will become an increasingly valuable resource as space becomes scarcer and scarcer, and more people move into cities for economic opportunities, or sometimes just simply because they're driven there by the effects of climate change. Today, more than half the world's population lives in urban areas, and by mid-century, it's estimated that it will be closer to 3 out of 4 people. Higher land prices resulting in higher development costs in dense cities such as Tokyo, Hong Kong, Seoul, and so on, have also driven the aggressive exploration of the use of underground spaces. Things like climatic conditions can also drive underground space development. For example, in places like Helsinki in Finland and Montreal in Canada, they have extremely cold winters, which make traveling outdoors quite uncomfortable. And this has driven the creation of extensive underground networks in these cities, allowing people to commute comfortably during the winter months and during the harsh winters. The same idea can also be applied to tropical climates like Singapore, for example, our neighbor Singapore, where underground space is also a refuge from the extreme heat, the humidity, and the heavy rainfall. When people think of going underground, most people think of basements, of subways, and sometimes roads. Most cities also put their rail infrastructure underground, particularly in the busy, dense central parts. But underground space is being used in increasingly interesting ways. One of our current projects that we're working on in Taiwan is a power cable tunnel, which is constructed dozens of feet underground without digging up any roads on the surface to lay the power cables. And this in turn minimizes disruption to traffic in the area. Underground caverns are also being used for commercial spaces, for car parking, and even utility plants, for waste management, wastewater treatment, and for purposes such as fuel storage depots. There are even underground data centers nowadays. Data centers are usually energy hoggers. They burn up massive amounts of electricity to keep the machines from overheating. But in Helsinki, in Finland, deep underground, computers are being kept cool with seawater, and the heat that they do generate is pumped up to the surface to warm homes on the surface. So we're seeing some really innovative use of underground space in the last decade. Given that underground space will become an increasingly valuable resource in the coming years, the conscious planning and management of this resource will also become increasingly important. In the past, it's always been on what I call a first come, first serve basis. So whatever you build today underground, let's say a tall building with deep foundations, someone else in the future will have to build around it or under it, even if they're building more complex infrastructure or something of significant, say, national importance like a rail line. So this is hardly optimal. Many cities around the world have already started or are starting to regulate the underground space with laws, regulations, and master plans. And many are also establishing digital databases of building foundation records, geological data, utility records, and so on for planning purposes. The private sector is also coming up with many innovative public-private partnership ideas to fund and develop underground spaces, when in the past it was almost purely the purview of national and state governments. Okay, so on to maybe a brief history of tunneling. From the time of the pharaohs in Egypt, tunnels have been historically built using what we call the cut and cover method. So this is essentially digging up a long trench in the ground to the required depth. Then you build the tunnel and you cover the tunnel again with the previously excavated material. Thus the term cut and cover. So this was done for many centuries until if I draw your attention to the picture on the left, the picture on the left is a very famous illustration in the tunneling world. This is essentially the world's first tunneling shield. The idea was that the shield would support the ground around it, protecting the tunnelers within, and this would minimize the risk of collapse while the tunnelers only expose the part of the ground, the small part of the ground that they were excavated, essentially what is called the tunneling phase. So Sir Mark Isambard Brunel and his son Isambard Kingdom Brunel were able to excavate a tunnel under the Thames River in London in the early 1800s. And the tunnel created an important connection between the north and south banks of the Thames that is still in use today, almost 170 years later. Previous attempts at tunneling in soft soils full of groundwater had been extremely difficult and were not particularly successful, and most projects were eventually abandoned. The application of this new technology heralded what I would like to call a new era of tunneling. So this is what modern day tunnel boring machines look like. The largest are over 7 stories tall. They can be over 300 feet long and they weigh thousands of tons. The front of the tunnel boring machines is called a cutter head, and it's essentially a big rotating drill that eats and chews away at the earth in front of it. The excavated face of soil or rock in front of the cutter head of these modern machines is now supported using pressurized air or fluid, which prevents collapse during excavation. And this allows for tunneling in a much wider range of geologies than was possible before. Of course, there have also been other incremental improvements in tunnel boring machine technology over the years. Most tunnel boring machines today are electrically driven. They can go faster, deeper than ever before, and are more robust. But all in all, tunneling is still a slow, laborious, and high-risk process, and a lot more innovation needs to come into play if we're serious about expanding our underground space. The challenges. Underground construction is very challenging technically. To give you a feel of this, when an engineer designs steel structures, for example, because steel is a very homogeneous and predictable material that's very well understood, an engineer would look at a safety factor of, say, 1.05 or 1.1, because steel is very predictable. In the nuclear industry, for example, safety factors, as far as I'm aware, are commonly in the range of 1.4, 1.5, and so on. But for underground engineering, factors of safety utilized sometimes go up to 3, and that's just how unpredictable tunneling can be. Which of course brings about other challenges like the niche skill sets required and the very high cost of building underground. When you build anything away from the surface of the ground, like say if you build upwards, skyscrapers and so on, costs go up the higher you build any structure. But when you go underground, your building costs go up significantly faster for every meter you go deeper. So if you look at public transportation systems, underground subways are always the most expensive per kilometer of public transportation. There's also a very special set of safety considerations like ventilation requirements, access and evacuation requirements, and other considerations like working in confined spaces, which also makes underground construction very expensive. There are also issues of complicated approvals, which I will touch on shortly. But all in all, improvements in underground technologies have enabled great strides in urban development in the last years, but the complexity and the unpredictability still inherent in underground construction are indications that many challenges will remain in the coming years. So I've said earlier that it's more expensive to build underground than to build above ground. When building underground, structures must be able to withstand the horizontal earth pressure forces, the vertical forces from the soil above the structures. They must be sealed from groundwater intrusion. And some underground structures may even need to be designed for seismic or earthquake loads, depending on which part of the world you are in. Construction is far simpler above ground and much more accessible as well. So this is one of our underground stations on the Putrajaya line. You can see it's surrounded by a lot of high-rise structures. The foundations of those structures also interact with our structures. And there are challenges, like a whole plethora of challenges. The simple fact that it's just a huge hole in the ground, and the amount of rain you have in Malaysia, just dealing with the water that goes into the hole it's a challenge in itself. So in tunneling, there are also a lot of niche skill sets required. For example, tunnel boring machine operators are in such high demand globally that typically before a TBM operator has completed a job, he or she will already have another one in place waiting. On the Putrajaya line, we had to look for 36 TBM operators at one go, and it was a complete nightmare, and that in effect also sort of drove our initial, let's say, inclinations to develop an autonomous TBM. But John will tell you a bit more about that story later. Tunneling is also a very dirty job with harsh conditions. This is me quite a number of years back, working in compressed air conditions. So we use compressed air to support the tunneling phase. In this picture was taken at 3 bars of pressure, which is essentially akin to diving about 100 feet underwater, if any of you are deep sea divers and so on. We also work in confined space where ventilation is limited, and it's very hot, it's very humid, and the temperature can go over 110 degrees Fahrenheit. So it's quite a harsh, uncomfortable place to work in. I spoke earlier about increasing the regulation of underground space, but I'll briefly tell you what it's like in my home country, Malaysia. Underground space in Kuala Lumpur, Malaysia has historically been not particularly well regulated. There are no pre-planned tunneling corridors. The existing data of utility records, foundation records are often inaccurate and non-existent in some cases. And you can imagine how difficult it makes underground construction. Laws pertaining to underground space are also very different in different parts of the world. In some countries, if you own a piece of land, you only own the surface up to a few feet below the ground, so including your basement. But in Malaysia, when you own a piece of land, you own it to the core of the earth. So you own all the underground space underneath your plot of land as well. So this brings about issues about concerning land acquisition and so on when we're building public infrastructure, and it makes things quite complicated and quite bureaucratic in general. I mentioned earlier that Kuala Lumpur in Malaysia has no pre-planned tunneling corridors. So when we were building our metro lines, it meant that despite our best endeavors in selecting tunnel alignments to minimize land acquisition and impact to public and private stakeholders, unfortunately, we still had to demolish a few structures along the alignment. A lot of the structures along the alignment also needed to be protected and strengthened, and this entailed installing new foundations, treating the ground, and removal of old foundations, and it's quite extensive work. So just to contrast, Singapore, on the other hand, seems to be moving in the right direction. In 2014, the Urban Redevelopment Authority in Singapore called for an underground study to support the efficient and coordinated use of Singapore's underground space as a resource. So this is essentially a summary of how Singapore manages its underground space now. They have horizontal corridors at different depths for different purposes. Shallower corridors are for pedestrian links, for bus interchanges, for bike parking, and so on. And below that, they have the underground road and rail networks. And as you go deeper, at the depth of about 150 feet, they have a sewage system, and they have caverns that are used as reservoirs for different purposes. So as you can see here, integrated master planning is essential, and this requires coordination and inclusion of the government and private stakeholders and the public, especially to properly link the underground infrastructure to existing surface infrastructure. For something a little closer to home, for you guys, for most of you guys, I'm a big fan of Elon Musk, who is famous for dabbling with electric vehicles, reusable rockets, and satellites that can beam down high-speed internet to the most remote regions of the planet. Really high-tech stuff. But in 2016, he set his sights on tunneling, and his idea was to create a company that would solve traffic by building a system of underground tunnels. Elon founded the Boring Company in 2017, and he said that the problem with tunnels was that they take a long time to build and are very expensive. He said that something needs to be done to revolutionize the tunneling, to revolutionize the tunneling industry, and we would need to be able to build tunnels way faster for a lot less money. And he's absolutely right. Well, most construction professionals will tell you that usually it's not the speed of tunnel boring that you need to worry about. It's the approvals, it's the environmental review, it's the bureaucratic procedures, it's the permits. And that was a very painful and hard lesson that Elon had to learn just like the rest of us. So after about a year and a half of digging and construction, the Boring Company officially opened its first underground loop in Las Vegas to the public this year. But tunnel experts in the industry were quite skeptical if they will ever deliver their end game, their final promise. Remember in 2018 when Elon unveiled his tunnel boring machine to the public, a lot of tunnel experts saw the picture and which is the picture on the left, and they laughed it off because they could see that it was a very basic off-the-shelf tunnel boring machine, and it was unlikely to deliver the promise of building tunnels way faster and for a lot less money. So a lot of the industry remains quite skeptical, but we at Gamuda, we take quite a different view. We are very encouraged by companies like the Boring Company, which are willing to push the envelope. While Elon hasn't yet delivered extremely groundbreaking innovation in this space, We think that, having more visionaries, more forward thinkers, more innovators, more disruptors like him and the Boring Company in this field is definitely welcome by our book to accelerate the pace of innovation in this industry. And we continue to, track their progress and developments with a lot of optimism. So I think this is a good point to end with, and transition into the next part of our discussion, which will be on innovation in tunneling. So on to you, John.
All right, thanks so much, Justin. I really resonate a lot with what Justin said about the need for many companies to embrace innovation in this space. And we welcome this kind of ecosystem within the industry. I myself started my career with the MRT project, doing innovation and developing some of the things that Danny and Justin have alluded to, the autonomous TBM. And I'm going to sort of just bring us through some thoughts about innovation in the industry and innovation in tunneling, and what is really needed, in order to bring about greater use of underground space, and also create this ecosystem of software, tools, platforms that can really bring this about, which I think is really crucial, having that ecosystem. So if we move to the next slide. So in terms of innovations needed, there's plenty of spheres where innovation is required in this industry. First of all, looking at design and analysis for underground technologies, I think a lot of times in the tunneling world, maybe I'll give a context first before I talk about the innovations needed as well. Construction is known to be one of the least digitized or least digital industries in the world. There was a report in 2017 by McKinsey, where they were talking about how industry is, construction industry is very close to agriculture in terms of its adoption of technologies. And we are in a way trailblazing a path forward. And there's some areas that require these sort of innovation. So, for example, in design and analysis, I'll bring us through some of the innovations that we're using currently in our process. But I think the industry has moved a lot into digital tools to help design projects early on in a digital setting. Tools like AutoCAD have been around for a while. New ideas such as BIM and digital engineering, which are gaining traction in the world today, help to, in a way, promote collaboration, promote different parties, because in construction you get multiple stakeholders involved in such a mega project. So having that platforms in order to collaborate, in order to have that transparency is very important in order to avoid reworks, to avoid mistakes, right, and be able to construct in a very efficient way. Technologies for underground site characterization, including geological setting, rock and soil properties, existing underground infrastructure. I think it's a challenge that Justin has alluded to earlier on in his speech, where in underground space, we realize that there's a lot of risk. And the risk is predominantly due to things that we do not know, right? What is the ground conditions at the point which we're tunneling? Do we know it to a T? And at this point of time, what are the things that we do? Well, for example, we take things like borehole samples, right? We take samples at specific points along the alignment, but we can't take it at every point in the alignment. So that is one place where definitely there needs to be some form of innovation there, right? To be able to know exactly what we're tunneling through, what are the risks involved in those particular places, and how to mitigate them, right? Technologies for construction of underground space. TBM tunneling itself is a method that has in a way not changed much in the past maybe 100 years. TBMs have been around for quite a while, and the technique or how it's done, the underlying principles are roughly the same. Of course, with a bit of new changes to the methods, but predominantly there needs to be a big shift if we are to tunnel greater lengths at greater depths. There needs to be a fundamental shift in the science of how we tunnel, right? In the methods that we use. Effective asset management is one that is, of course, important because we're dealing with a lot of assets on our construction sites, from machinery to maintaining the machine and things like that. So that's a very important point. And promoting sustainability and resilience. TBMs are driven by electricity predominantly, and sustainability right now, as we talk about climate change and as we talk about rising sea levels and things like that, we need to ask ourselves, how can we make tunneling a more green space? And how can we ensure that what we're doing does not contribute to the overall climate issues that we're having today? And at the same time, also maybe not even just to avoid contributing to the issues, but be able to make a positive reduction in, for example, carbon dioxide levels. So there's a lot of space or spheres in which innovation can happen. Maybe if we just cover some of the different innovations that we ourselves have embarked on, it will provide greater context. So Justin, you can move to the next slide. Danny alluded to this a bit earlier in the presentation about the variable density TBM. So like I said, the way of the general method of TBM tunneling has remained similar over many decades. But what we have innovated is we saw a problem being the ground conditions in Kuala Lumpur. Karstic limestone is a very difficult ground to tunnel in. And what we did was look at what we could combine, what existing technologies we could combine to produce a tunnel boring machine that could reduce this risk. So we looked at, the earth pressure balance machines, which are very common, and also the slurry machines that are in wide use. And what we've done is very innovatively combine the two to provide us this multi-mode capability, so that we're able to leverage on different mediums or different operating principles in order to help us tunnel through a wide variety of ground using a single machine. So that is something that has really helped us on our projects here in Kuala Lumpur. Not only do we go through one type of ground, but we go through multiple types of ground. So from karstic limestone to Kenny Hill formations, which is just soft soils, and also hard granitic formations. We've been able to gain economies of scale by not having to buy specific machines for very specific stretches, but we've been able to use one machine that is able to tunnel through all these different geologies at the same time. So that's one innovation that we're very proud of. It's one that we have innovated together with our TBM manufacturer, Heron Connect. The next innovation that we have is in the area of the autonomous tunnel boring machine. So this is a project that myself and my team have worked on with Justin, and this was recognized as the Technical Product Equipment Innovation of the Year in 2019 in Miami, and as well as the Innovation in Tunnel Excavation for the NCE Tunnel Festival in London. And the idea for this was really that now that we're living in this digital age where we're talking about AI, we're talking about data, and we're talking about how data can help us in all spheres of life, we started asking ourselves, could we use data that's very abundant in these machines, sensor data and things like that, to help us drive a tunnel boring machine? Now, of course, there will always be a question of, oh, how do we do this quicker than, say, autonomous cars, for example? But if we look at the tunnel boring machines, it's a much more constrained problem in the sense that we are digging very slowly underground in very confined conditions. And what we did was we started looking at, the available sensor data and things like that, being able to then replace the operator by mimicking the things that the operator does while driving the machine to keep it on point, on target, and also at the same time be able to mitigate disasters. Because a lot of times, out of the pool of TBM operators that we have, of course, there are varying levels of experience and varying levels of skill sets, and you don't really get a consistent mix across the board. And so the thing with the autonomous tunnel boring machine is that it gives us the advantage of consistency. An algorithm that does what it's programmed to do over and over again. in a very reliable manner, 24/7. So this was really a tunneling game changer, and we were recognized for it. We also combined that with our tunneling control center as well, where we host a lot of the data digital web portals that we have, which I'll show in a bit, that help us to aggregate our sensor information, our site information, our cameras, in order to gain a bird's eye view of what's happening on the tunneling site. If you move to the next slide. As I said, it's a tunneling game changer because we're transforming operators from semi-skilled operatives to highly skilled TBM experts. We've improved the quality, reduced our rework. It's a scalable system where we're able to deploy this on as many machines as we need. We've reduced our risk, improved productivity, and also safety. So next slide. The other things that we're working on right now is looking at how the cloud plays a role in this as well. So looking at how, with all the data that we have, can we move our data into the cloud and be able to visualize them and apply algorithms to them in order to extract information or insight. And so the result of that is it's a portal that we've developed called Tunnel Insight. So we utilize data from our sensors, be able to analyze them in real time, and provide insight to users or to our shift crews. A large problem most of the time is that data shift crews come and go. Their shift ends and another crew comes on, and they don't have the full visibility of what has happened in the previous shifts. What are the trends that have happened? And what we have done is been able to look at trends over a long period of time, 1 week, 2 weeks, and be able to spot anomalies or patterns that we think are worthy of investigation. So this has also in a way helped us with our tunneling process. We're working on the next version as well, where we're trying to include information from building sensors, from sensors along the alignment, to also tie that in with our TBM data to be able to have a very clear bird's eye view of the risks and be able to mitigate them, nip them in the bud very early on. Moving on. And finally, in some other types of innovations that we have on the project include, like I said, in terms of design, looking at building information modeling. So we are one of the first companies in this region to be awarded BIM Level 2, which is a certification by the British Research Establishment, which basically says that we are qualified and we are competent to produce things like these, our BIM models, our 3D BIM models, which are very detailed models of our stations, of our tunnels, right? So we have a very clear understanding of the construction sequence of what goes in to the stations, as well as the integration with other software platforms that we've developed. So we've developed using these 3D models, our BIM AR, our augmented reality suite. What it is basically an app on an iPad that allows you to scan the environment and be able to overlay the BIM model over the actual camera feed. So you're able to see what the final product needs to be. Another point of innovation is, of course, here, our drone imagery, our drone portal, where we have drones flying our site every month and capturing 3D mosaics of our site. So we're able to use that for analysis, and we're able to use that for discussion purposes, so that people are able to collaborate, see the real-time progress of our sites and things like that. So yeah, we've really tried to implement a lot of different types of innovation into our construction process, from 3D models to augmented reality, which we developed in-house, to our drone portal, which enables us to also have a bird's eye view of our site and be able to collaborate. So with that, maybe I'll just like to end here and state that, really this space, there's a lot of opportunities and there's definitely a lot of spheres that need more innovation so that we can further utilize underground space throughout the world.
Okay, perhaps we'll move on to the questions. I think we don't have too much time left. I see two questions in the Q&A box. Maybe John, you can take the first one from Sharil Ibrahim. Does a human or operator need to do decompression to go from the tunnel boring to the ground like diving?
Yes, correct. So what happens is that when there's an intervention, the machine stops, a person goes into a man-lock where he's pressurized to the pressure of the front face. When he's done with his work, he comes back into the man-lock and is depressurized back to atmospheric and out through the man-lock again, back into the other side of the TBM.
Yeah, so it's quite a complicated procedure that there are also regulations in how you do your decompression and so on. There's another question from Kamesh. How does tunneling change city planning? Are cities being planned around tunnels? So that's a very good question. I alluded to part of the answer in my previous, in what I said earlier in the presentation. So some very progressive, forward-thinking cities are actually doing, full underground master planning. They're regulating and master planning the underground space. So the idea is, because the deeper you go, it's more expensive. So they will prioritize critical infrastructure and give them the priority in the right of way. But in some other countries, for example, they're still adopting a first come first serve type approach, which is hardly optimal, because a simple foundation of a building can actually increase the cost of a critical rail tunnel by many hundreds of millions of dollars, and that's quite unnecessary if that was being planned with foresight. So we hope this governments of the future are more conscious about how they plan and plan their cities and plan their underground space. There's a very general question. How long could a human live in the tunnel? Perhaps the natural inclination for human beings is not to live underground. So a lot of additional efforts and costs have to be put into to make the underground space habitable. There are ventilation requirements. There are also things about how we need sunlight and how that can be provided underground. So there are a lot of schools of thought about this, and a lot of research being done in this space. But a lot of living underground in itself has a lot of advantages. You're protected from the elements. Cooling and heating also becomes less of a problem, so that there's less energy use. And as we're looking to in the fight of climate change, perhaps the use of underground space will become increasingly important in the coming years, perhaps, let's say. Ravi, do we still have enough time for questions? Or
I think maybe one more question.
Yeah.
Pick the one you like best.
Yeah. So how is Gamuda educating the government in terms of implementing a forward-thinking smart city planning, especially in Malaysia? Well, that's a very difficult, loaded question. As private entities, difficult to say this, but we have limited scope in influencing government policy, especially when there are changes in governments and so on. But because sometimes we get quite involved with the alignment planning and that kind of thing, and also we have a very close relationship with the client. So to a certain extent, we're able to say, hey, for the future, perhaps it's good to allocate a corridor for this, plan for more lines and have a master plan overall, at least have indicative corridors. But these things take time, and it's an issue of maturity with time as well. And I think governments can only get better at doing this. Yeah.
Actually, I just want to chime in on that. Gamuda has a history of basically disrupting policymakers' thinking. I started off the talk with the smart tunnel. No one ever thought that flood water and cars can go together in the same tunnel, but we managed to convince the government and the regulators here of doing so. And similarly, when we suggested to do tunneling under very tough karstic limestone, again the government thought, hey, all the engineers from Europe that we spoke to said that was impossible. But again, Gamuda managed to prove all of them wrong. And I know stateside, Elon Musk is doing the same thing. He proved that he could do it in Vegas. And I look forward to the day when, the loop, as I think he calls it, will be a thing of reality in California, because he was inspired by he was inspired to do it by being caught in a traffic jam, or at least that's the urban legend in Los Angeles. And he's since moved to Texas anyway, when hopefully there's less traffic. But traffic is a very key problem everywhere, and we believe that in Gamuda we will continue to influence policymakers, not just in Malaysia but everywhere in the world, now in Australia, Taiwan, and so on, and who knows, soon in the States as well. Maybe we can join Elon. But the quick answer is yes. I think innovators and disruptors will always influence policymakers, and hopefully they will then work in tandem with us to bring a bright new future for everyone.
Well, with that, I want to thank you, Danny, Justin, and John, for this incredibly inspiring kind of talk and discussion.